Hi, and thank you for joining me in this video on error analysis. In this video, we're going to start talking about statistics. And statistics isn't a branch of mathematics that deals with random data. It also relates to probability theory and also the data collection and processing of that data. Statistics uses probability theory to evaluate the reliability of observations and also, based on a sample data set, make inferences from that data set. Also, it helps us organize and describe the data. It answers a lot of questions, things like how often do certain observations repeat themselves, or what's the best estimate of the true value, what is the accuracy. Also, how is the data distributed randomly? How precise are the measurements? And then also, if you have two different sets of data, are they correlated? Is there a discrepancy or are they similar? As an example, let's say that we have CDs, compact discs, that we measure the diameter. And we had 5 people measure diameters of the CDs, and they came up with 5 different numbers, as you can see here. The best estimate to the true value of the diameter of a CD would be to sum up all of the values of the CDs and then divide them by the number of observations or measurements that were made. That'll give you your best estimate, or our average or mean. In this case, with the CDs, if we take the numbers, add them up, divide by 5, it gives us an average of 112.8 millimeters. The deviation, or also known as residual, is how much each measurement differs from the mean. So you take the true value, or the mean or the average, subtract the measurement, and that gives you D, or the deviation. Here's an example with our CDs. We had an average of 112.8 millimeters. Each measurement of the CD's diameter can be seen in the left column of this table. And then subtracting that number from the average, 112.8, gives us these numbers that are on the right, which are called deviations. As you can see with the calculations of these deviations, sometimes they're positive, sometimes they're negative. It would be nice to get a handle on the spread of this data and how close it is to the true value. So maybe we can do the average. We'll take those numbers and average those. So here's our average. We're going to sum up all of the deviations and then divide it by 5. But if you'll notice that when we sum up all of the deviations, that gives us 0 on top. So actually the sum of the deviations is 0. So that is a problem. We can't get the average, but there's another way to get the average. If we square each one of those, the negative numbers become positive, and then we can divide it by 5 and get the average of the squares. So this is what we call the variance. The variance is taking the deviations, each deviation, squaring it, and then adding them all up, and then dividing by the number of observations. In this case, you can see the deviations. We squared them. That's the right-hand column. And then in the calculation, we're just adding up each deviation squared and then divide that by 5. And that gives us a variance of 8.6. The standard deviation takes this one step further. If you take the variance and take the square root, the positive square root, then that will give you a feeling for the spread of the data. It kind of gives you the average variance, or the average distance, or the average deviation. Let's put it that way. The average deviation of the measurements that you made. Here's the standard deviation for our CD measurements. As you can see in the table, on the left-hand column, we have all of the deviations. We calculated those. On the right, we square all those. We added up the squares, divided that by 5 because we have 5 measurements, and then we took the square root. and that gave us a standard deviation of 2.9. So standard deviation 2.9 millimeters, and you can think of that as the average deviation of our sample. And looking at the deviations in the left-hand column, you can see they vary from 4.2 all the way down to minus 3.8. So after we square those, take positive, add them up, and divide them by the number, that gives us a standard deviation of about 2.9 millimeters. So the standard deviation is a measure of the precision of the measurement. So we talked about precision before. We said precision, we have good precision if all our measurements are very close to each other. If they're not, then you have imprecise measurements and your standard deviation is very large. It's far away from the center, the mean. But if all the measurements are very close together, then they'll be very close to the mean or the true value. They'll be surrounding the best estimate. So that's a little bit about statistics, very elementary statistics.